Hey class, welcome to the first lecture from week 20. Now in week 20 today, my video is a little bit more freeform because we had a guest speaker today. Dr. Guccione came and talked to the class, via Zoom of course, about the scientific method, kind of a common language that scientists use. You'll notice that a lot of the key terms this week go way back to week 1, 2, 3, when we started our interactive student notebooks. We've got 20 weeks worth of lessons now in there, or 20 weeks worth of notes. Don't forget to go back and look at some of those when we're talking about the metric system, ordered pairs, things like that, because remember, it all builds on itself, and we keep going back on the math because math is truly the language of science. Some of the things that we talked about in class today were, for example, Dr. Guccione used as her example the 1986 Challenger disaster, when there was an O-ring that was on the space shuttle. Now, the space shuttle was going to launch in Florida. It got very, very cold for a couple of nights there, unusually cold, below freezing for Florida, which is very strange. And when the shuttle finally was cleared to launch, one of the O-rings failed. And the reason they were able to figure out exactly what went wrong, partly, was due to the work of this man who you've seen in class before. We've talked about him quite a bit. Dr. Richard Feynman. He was on the committee that studied the 1986 Challenger disaster, and using the scientific method, using very step-by-step techniques, he was able to find out about how this disaster happened. One of the examples that we gave in class about the common language that scientists need to use had to do with the 1998 Mars polar lander. It was supposed to land on the North Pole of Mars, I believe. He was supposed to land on one of the poles of Mars. I believe it was the North Pole. And unfortunately for the Mars polar lander, it crash landed. The pieces of it can now be seen scattered across the pole of Mars. Why? It turns out that some of the programming team that worked on it used the metric system. Some use the English system, the US system. The US sort of lags behind the world right now in adopting the metric system. And it's critically important for scientists across the world to have a standard language when it comes to talking about certain events, when it comes to going through the scientific method. If you're working in the United States, or if you're working in South Africa, Australia, France, and you come together at a conference, you have to have a common language. That's what math is. Math is our common language. So no matter if you have Miss Weideman, Miss Alderson, whomever your math teacher here at IBL is, or wherever you are, you're going to see a couple of things that tie in directly to some of your beginning algebra concepts here. So there's the key terms. You'll notice x-axis is here, y-axis is here. We talked about those way back when we did our pendulum experiment. Dependent, independent variable, control variables, and particularly we're going to talk a little bit about ordered pairs, which you've seen when we talked about putting data onto a graph. What else did we talk about today? Oh, a little bit about programming. One of the things that Dr. Guccione talked about was if you were trying to describe, for example, over Zoom, like we did today, how to do a drawing. If you are just doing it with verbal cues, verbal communication, how do you make sure that the person is recreating the drawing that you had? It's very, very important that we use step-by-step instructions. There's a lot of crossovers between computer science and the scientific method. As a matter of fact, I used to teach programming, basic, beginner's all-purpose symbolic instruction code. Not too many people teach with that anymore. They've moved on to some other things, but the idea is this. In computer programming, you give step-by-step instructions to the computer because the computer doesn't know anything on its own. A computer, whenever you hear somebody say, oh, that must have been a computer error, it wasn't a computer error, it was a human programming error. So the scientific method is very, very similar, and there's a lot of crossover with some of the basic techniques that you learn about when you're computer programming. If anyone watching this ends up wanting to be a computer programmer when they get older, they want to program games, they want to program for science, one of the very first things you do is you learn about sequential programming methods, and that is a lot like the scientific method. One of the other things that we went into, that she went into with the class, was we had a joint class with Miss Lakadas here, third period and fourth period, was a little bit about describing how to get to a particular location on a map. This is a good tie-in with something that you're probably doing in your math class right now, which is the Cartesian coordinate system. Again, a quick example up on the board behind me, and it goes along with our vocabulary terms this week. When you're talking about a coordinate system, if you're talking about the point 2, -5, or negative 5, 2. They've got the same numbers in there, but when you're talking about ordered pairs, we always have to talk about which number comes first and which comes second. Again, there's rules for this, and if you always know that the x value comes first, you move on the x-axis first. That's the axis, of course, one of our key terms. And then you move on the y-axis, either up or down, and you end up in a particular coordinate. Check out the two dots that are behind me, the 2 points on the board. I've got the point 2, negative 5, or the point negative 5, 2. Very different points. So if you're talking about a map and it wanting to end up at the correct location, it's critical that as scientists, as citizens, we have a common language. That common language, mathematics. If you look at the real world tie-ins, great example of this is climate change. When you're looking at things that we had in week 19, when we were talking about, for example, the carbon cycle, one of the biggest things that scientists over the last couple of years have been sounding the alarm about is the fact that more carbon dioxide added to our atmosphere, particularly through burning fossil fuels, warms the climate. We've known that this is possible for at least 100 years now, but especially in the last decade, the data has really shown that there's almost a direct relationship between the carbon dioxide that us humans are burning and putting up into the atmosphere and the global temperatures. That being said, that shows where it's critically important for scientists and people around the world, whether they're scientists or not, citizens, policymakers, people in government, to have a common language when they're talking about this. Part of that is it takes opinion somewhat out of it. Instead, you can look at the data. A lot of times you hear people talk about the cold, hard data. Yes, because when you're looking at the data, you might remember going back to the very, very beginning, Richard Feynman, believe at one point or another, maybe 2 weeks in a row now, I think I've put his quote up on the board where he says, you can have all the most amazing ideas that you want. You can have any theory that you like to put out there. That's great. But if it's not backed up by the data, if it's not backed up by experiment, you're wrong. You have to go follow the data, follow the scientific method to get to your answers. That was the main thrust of Dr. Guccione's lecture today. Don't forget to check out the key terms, which I'll put up there online. There's 10 of them this week. And if you look at the Wednesday quiz again this week, because it's a little bit of a goofy week, we're going to put that Wednesday quiz again online off till Friday. So both things this week, the vocabulary and the Wednesday quiz, the online quiz that we always have. Again, always based on your interactive student notebooks, will be both due by Friday at 3 o'clock. Have yourself a wonderful week 20, everybody. I hope you enjoyed the lectures today. I'll write up these notes and get them on out there. Take care. See you later. Bye-bye.